All right, let's do another arc trajectory problem. Okay, so this is what you got. You got level field, right? Okay, and then it's launched at 62 degrees above the horizontal at 28 meters per second. So that's like that, and this angle here is 62 degrees, right? This is 28 meters per second, right? And then what we want to do first is we actually want to figure out these components of horizontal and vertical velocity. So whatever this horizontal one is here, right? And then we want to do this vertical guy here, right? And then that angle is 62 degrees. Okay, so this side here is going to be 28 sine of 62, and this side here will be 28 cos 62. So let's just bust that up. Make sure you are in degrees though, right? So 28 sine 62, enter 28 cos 62. So the opposite side is 24.72. It's always good to write down 4 numbers. And then this guy is 13.1, I'll say 13.15. I'm just rounding nicely to 2 numbers there, right? Okay, so now we've got these things here, right? All right, that's important. It's important that that person call the office. Okay, so this thing here, the 13.15, that goes here and here, because that's our velocity the whole time we're in the air, right? We're gonna go like that, right? We'll be moving to the side at that speed, right? My initial vertical velocity is 24.72. Right, so to start off with, it's plus 24.72. When it hits the ground, it's negative 24.72. Right? Okay, so let's see. And then this is negative 9.8. Right? And then these things always work out the same way, right? The first thing you do is you solve for the time. So I'm going to go VF is VI plus AT. Right, so that's going to be negative 24.27 equals 24.27 plus negative 9.8 times t, and we don't know what t is, right? Okay, so let's see. Times 24.27, right? Or 72. Oh my gosh. Dyslexics should not be physics teachers. That's 7.2, that's a 7.2. All right, here we go. 7.2. All right. That's what it is. Okay. Divided by 9.8. So when I do the time, I get about 5.045. When I solve for that, right? And then the time goes across, right? 5.045. And then we do what we always do on this side. We're always multiplying velocity by time, right? So I'm going to go times 13.15. And I get 66.34. Right, so let's see, time it's in the air, 5.05 seconds. Yes, that is correct. Let's see. Before it hits the ground again, it goes 66.3 meters. That's correct, right? And then it says, what's the greatest height the ball reaches? What is its speed at this height, right? Well, to do that, we really actually have to set up another little thing here. So let's do that. Let's go doot, horizontal, vertical, right? X, VI, VF, AT, right? Now it looks like we have to do the whole thing over, but we really don't. Okay, so this guy is 13.15. This guy's 0. This is negative 9.8. And then at the top, remember, we're 0, right? Because we're looking at it right there, right? And then this guy is 24.72. Right? And so what we want to know is we want to know the height, okay, the greatest height that it reaches, right? So to do that, I'm going to use VF squared is VI squared plus 2AX, right? I'll do that on this side here, so 0 squared. So remember, the final velocity at the top is 0, right? Because if it's not 0, it's not at the top, is it? Okay, so then that equals 24.72 squared plus 2 times negative 9.8 There's x. There's an x there. You can't even see it. It's so small, right? Okay, so now I'm going to solve that, right? So 24.72 squared divided by 2 divided by 9.8 is 31.177 is what I'm getting. Right, so that's the height that it reaches, right? So just set up another thing here, right? We really didn't even need to set this up here, but I just want to show you something here. Okay, so there's our greatest height. And then as far as how fast is it going, look at this. If you figure this out, here's our final velocity. At the top, it's going 13.15 to the side, like this, right? And of course, it's not going up or down because it's at the top. So its speed is 13. That's really 13.15, right? It's actually 1.4 or something like that. 1.45 something. I don't know. Okay. So if you round it to 3 places, it's actually 13.1. Okay. So that's how fast we're going at the top. So when they ask you what is the speed at that height, the speed is just always whatever your horizontal velocity is. It came from here. Okay. At the top, all you have is that horizontal velocity. That's not so bad. Is that bad?